Hi everyone, in this lesson we are going to go over law of cosines. In the previous lesson we went over the law of sines which was applicable for three specific cases. It was angle, angle, side, and then angle, side, angle, and then angle, side, side. Now law of cosines is applicable again to oblique triangles. Remember, an oblique triangle is a triangle that does not have a right angle in it, and it is applicable to two specific cases, and those cases are side, 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 and then side, angle, side. We can use the law of cosines formula to solve for either an unknown side or an unknown angle in a triangle. And here is the law of cosines, and you can see there are three different forms on the left hand side and then three other forms on the right hand side. Now the ones on the left hand side, we use them to find a side length. So for example, if you're trying to find the length of the side A, the lowercase letters are all side lengths, remember, and the uppercase letters are all angles. So if you're trying to find side length A, you would use this formula. Side length B, you would use this equation, and then side length C, you would use this last one. Now the three formulas on the right hand side, these are if you're trying to find an angle. So if you're trying to find angle A, you would use this one, angle B, use the second one, and angle C, you would use the third formula. Now, none of these formulas need to be memorized. They're all given to you on the test. You just need to know that they are only applicable for these scenarios when you're given all three sides, or a side, an angle between the sides, and then the other side. Now let's take a look at some examples and see how we apply the law of cosines. So, like I mentioned in the previous class, every triangle has 6 pieces of information. It has 3 angles and then it has 3 side lengths. And out of those 6, you're always given 3. So what I'm going to do is first I'm going to label this triangle as A, B, C. Then let's see what information is given to us. First, they have given us side length A is equal to 10 meters. Remember, side length A is always opposite to angle A. So they're talking about this side here. This is side length A. And they have given that as 10 meters. Then the second piece of information given is that side length B equals 4.5 meters. And side length B is opposite angle B. So they are talking about this side length here. So that equals, B equals 4.5 meters. Now the third information given to us is that angle C equals 105 degrees. And angle C is right here, so that is 105 degrees. Now look at the location of these 3 pieces of information given to us. They have given us a side, and then they have given us another side, and they have given you an angle that is between the sides. So this is side, angle, side. So that's the type of triangle that we are looking at, side, angle, side. And we have seen up there that when it is a side, angle, side triangle, then we can use the law of cosines. So we're going to apply that here. So since they have given us 3 pieces of information, we have 3 other pieces of information left to find. So those 3 are angle A, angle B, and side length C. So those 3 are our unknowns, and we are going to find them one by one. Now let's take a look at the formulas up there and see which one we can start using. So we have been given a lowercase a lowercase b, and an uppercase C, right? 2 sides and an angle. So let's try to find the formula where we have those 3 pieces of information. So we have uppercase C a lowercase a, and a lowercase b. You see all three of those things here on the right hand side of this last line here. So that means this last line can be used to find side length C, and that's what you see here. But then pay attention, this formula is giving you square of the side length C, but we are trying to find actual side length C. So to eliminate the square, we need to take square root on both sides. So this formula will now give you side length C. So I'm going to bring this down here and write it down in the problem and then plug in those values. So side length C equals square root of a squared plus b squared minus 2ab cosine of angle C. Now I'm going to plug in everything into that formula. So square root, first I need a squared, a is 10, so I need 10 squared, plus b squared would be 4.5 squared, minus 2 times a is 10, b is 4.5, and then cosine of angle C, and in this case angle C is 105 degrees. Now all I need to do is plug in this whole thing into the calculator, but make sure your calculator is in degree mode before you do that. And remember, this square root is extending for the whole thing all the way till the cosine of 105. So go ahead and plug into your calculators and then see if you're getting the same answer as me. So once you're done, go ahead and check your answer. The answer I got was that side length C equals 11.981, and since A and B, the side lengths were in meters, this one is going to be in meters as well. So we have now figured out side length C. That leaves us with these other two angles to find. So we do have formulas up there to find angles. So for example, if I'm trying to find angle A, this would be the formula where I would plug in everything. Notice everything inside is all side lengths, and we have just calculated the last side length. So we know all A, B, and C here. So that means I can find any of these three angles here. What I'm going to do is, since I already know one, I'm going to use these formulas to find one other angle, and then the third one we can figure out by subtracting them from 180. So I'm going to start by finding angle A. So this time I am not going to write down the formula, but I'm going to directly start plugging in since I don't have a whole lot of room here to do that. So the formula for angle A is going to be inverse cosine. And remember, to get inverse cosine on your calculator, you have to do second and then cosine. That will give you inverse cosine. And inside, we are first, in the numerator, we are first writing down a squared. Now in this case, a is 10, so you have 10 squared, minus b squared, but b is 4.5, so 4.5 squared, minus c squared, and we have just calculated c and we got 11.981. So 11.981 squared. And then I'm going to divide all of that by negative 2 BC. That means negative 2 times b is 4.5 times c, which is 11.981. Now I'm going to plug in this whole thing into the calculator and figure out the value or the measure of this angle A. So at this point, go ahead and pause and then try this on your calculator by yourself. And when you have your answer, you can unpause the video and then see if you're getting the same answer as me. Now the answer I have is 53.728 degrees. So that gives me the measure of angle A. Angle C was already given in the problem. So the only thing left is to figure out the measure of angle B. Now I'm not going to repeat this entire lengthy formula to do that, because once you know two angles in a triangle, you can easily figure out the third one. So to figure out that angle B, I'm going to subtract from 180 degrees angles A and C. So A we just calculated 53.728 and C was already given in the problem as 105. So I'm going to add them up and then subtract from 180. And that is giving me 21.272 degrees for angle B. So now we have completely solved this triangle for all the missing pieces. Okay, moving on to example 2. So in this one, we have been given side length A as 6 inches, side length B as 10 inches, and side length C as 15 inches. So this is the side triangle. And if these are the vertices A, B, and C, so side A is 6 inches, B is 10, and C is 15 inches. So in this example, we are required to find the 3 angles since none of them are given in the problem. So the formulas for finding angles, remember, are the ones on the right hand side here. And again, we only have to do this twice. I just have to find 2 of the angles and then I can find the third one by subtracting them from 180. So first I'm going to find angle A. So measure of angle A. So measure of angle A is going to be inverse cosine of A squared minus B squared minus C squared divided by negative 2BC. And I'm going to plug it all in since all those lowercase letters are side lengths given in the problem. So A is 6, B is 10, and C is 15. And then we have negative 2 times B times C in the denominator. And when I plug it into the calculator, it's giving me 15.564 degrees. Again, make sure you guys do this on your calculator and check and make sure that you're plugging it in correctly and getting the correct answer. Now, angle B. So the formula for finding angle B, the second one on the right hand side, is inverse cosine of B squared minus A squared minus C squared divided by negative 2AC. And again, I'm going to plug it in. So first comes B squared, so 10 squared minus 6 squared minus 15 squared, and then negative 2 times A times C. And again, at this point, pause and do this yourself and check your answer. And the answer I got for angle B is 26.563. Now, once I have found 2 of the angles, I am not going to spend all the time trying to find the other one with this lengthy formula. Instead, to find angle C, I'm going to subtract the previous 2 angles from 180. So 180 minus 15.564 plus 26.563. And that is giving me 137.873 degrees. This one was also in degrees. So that's how you apply the law of cosines for the SAS and the SSS. Next up, we are going to look at some word problems with the same. I'm going to put that in a separate video so that the videos don't take too long for you to load. So we'll continue in the second one. So welcome to the second video. In this video, we're going to go over the word problems 3 and 4 and then the area problem number 5. So in problem number 3, they're telling us, they're talking about a women's softball field. So first I'm going to label all the parts here. So this one here would be the home plate. This would be the first base. second base. This would be the pitcher's mound. Now let's take a look at what's given in the problem. They're telling us that the pitcher's mound on a women's softball field is 43 feet from home plate. So that means from here to here, this distance is 43 feet. And then the distance between the bases is 60 feet. That would be these distances all the way around. So those are 60 feet each. And then they're asking us how far is the pitcher's mound from the first base. So this is the distance they're asking us to figure out. And one thing about the softball field is these angles are 90 degrees here. So if this is a 90-degree angle, this line is dividing it into two equal halves. So that means each half is going to be a 45-degree angle. Now I'm going to simply take this triangle here and redraw it here so that I can label it as triangle ABC. So here is the triangle we are looking at. We have the 45-degree angle here. Let's call these sides ABC. So angle A happens to be 45 degrees. And this 43 feet distance happens to be this side, which is side length C. So C is 43 feet. And the distance between the bases happens to be this side, which is side length B, because it's opposite angle B. And that happens to be 60 feet. And our unknown is this side length here, which is opposite angle A. So side length A is our unknown. Now, if you look at the formulas here for law of cosines, then you can see that this top equation is going to give us a way to find side length A, but then this one is actually giving a square of that side length A. So we have to take a square root to find side length A. So then A would equal square root of this long expression here. So I'm going to first write down this expression over there in the problem. So side length A is square root of B squared plus C squared minus 2BC and then cosine of angle A. And we have all of this information given in the problem, so we just need to plug it in. So B squared would be 60 squared plus C squared would be 43 squared minus 2 times B times C, and then times cosine of angle A, which happens to be 45 degrees. So go ahead and pause the video at this point and plug in all of this information. Once you have the answer, then come back and check if you have the correct answer. So the answer I have for this problem is 42.43 feet for the distance from the pitcher's mound to the first base. Now let's move on to problem number 4 here. So a submarine sights a moving target at a distance of 820 meters. So here is the submarine. So here is the distance of 820 meters. So that means this is the location of the moving target. Then a torpedo is fired 171.66 meters ahead of the target and 924 meters from the submarine as shown below. So that means the torpedo is being fired in this direction here. So they're asking us to find the angle at which the torpedo was fired. So that means this is the angle they're asking us to figure out in this problem. So first, I'm going to go ahead and label everything in the problem here. I'm just going to label this triangle as triangle ABC. So that means in this particular problem, they have given us side length A, side length B, and side length C, and remember everything is in meters. and we are trying to find angle A. So we already have a formula for that. We know that to find angle A, I have to use this formula here on the right hand side. That would be inverse cosine of A squared minus B squared minus C squared over negative 2BC. So I'm going to go ahead and do that math over here. I'm just trying to find enough room here to write all of that. So I'm just going to have to write really small here. So angle A would be inverse cosine. Now I'm going to do directly plugging in. I don't have space to write the formula and then do the plug-in. So first I need A squared. So in this particular case, A happens to be 171.66 meters. So square of that minus B squared. And in this case, B is 820. So 820 squared minus C squared. So C is 924 meters. So square of that. And then in the denominator, we have negative 2BC. So negative 2 times B times C. So it's just a one-step problem once you figure out what is given and what is being asked. So again, go ahead and try this on your calculators and then come back and check your answer. And the answer I have in this case for angle A is 8.999 degrees. Now that leaves us with the last problem. Now this one is not just application of law of cosines, but this one is to find the area of certain types of oblique triangles. So first up, I'm going to go ahead and label this triangle as triangle ABC. And then I'm going to fill in the information given to me in the problem. And then we can figure out what type of triangle it is. And that's when we can apply this formula. So they are giving us that side length A is 13 feet. So that would be here. Opposite angle A. Side length B is 7 feet. Opposite angle B, here is 7 feet. And angle C is 97 degrees. So that would be this angle here, 97 degrees. So this is a side, angle, and then side scenario here. So for that triangle, we can use this formula here to find area. And in this case, they have given us A, they have given us B, and they have given us angle C, everything that you see in the formula here. So again, just a matter of plugging in. So it's 1/2. A is 13 feet times B, which is 7 feet, times sine of angle C happens to be 97 degrees. So just plug in everything into your calculators, come back and check your answer. And the answer I have is area is 45.161 square feet. So that's it for the notes for law of cosines. With this, you should be able to complete homework number 1 in your packets, which is on both law of sines and cosines. So please do complete those. Next class, we will go over navigation and then vectors.